So, last time we were talking about these two firms, Supertech and Slowpoke. And we said that there were these four different states of the economy, and they each had a probability. And what do we say that those probabilities have to add up to? 1 or 100%, right? And so we know every state of the economy here, and we know the returns of these stocks in every state of the economy. Therefore, we know all the outcomes. Are we going to be using sample statistics? No, Mr. Mersch, what kind?
Population.
Yeah, population statistics. And so this is going to be your introduction to population statistics. And we're not going to be just adding, or doing the squares of the deviations, adding them together and dividing by n minus 1. We're going to be doing something different here. So this is going to require some additional skills on your part. Okay, now first of all, let's talk about what expected return is. I said last time, expected return is a SWAG. Ms. Minahat, what does SWAG stand for?
Scientific wild guess.
Very good, scientific wild-ass guess. It's our very best guess of what's going to happen. It's kind of like the weather forecast. Is the weather forecast always accurate? No, they told me my roof was going to get ripped off the other night in something called a derecho. No, I didn't. I don't even think I had any limbs down in my yard. So the weather forecast is not necessarily correct, and neither will be our expected return. It's just our best guess. So how do we go about figuring out expected return in a situation like this? If we were just doing sample, what would we do to find the expected return? If we had a sample of 4 returns, what would we do to find the expected return? Yeah, we just take the mean, right? We just add them together and divide by the number of returns. But now we're working with this weird probability stuff. We can't do that. So here's how we're going to go about doing that. What we're going to do is, by the way, does this look like Spanish or Arabic to you? Mm-hmm. Yeah, okay, so we're going to walk through it, so don't freak out. Okay, so we are finding expected return of stock I. In this case, we're looking at Supertech. And so don't let I freak you out. You can just think, in this case, I, Supertech. I think my dogs went outside. I hate it when it won't roll down where I can mute the watch. I hate that. Okay, back to the story. Stock I here is Supertech. Now, the states of the economy, how many states do we have here? 4, right? And so in this case, J is going to be, or N is, oh sorry, I messed something up here. It should be, J is 1 to N. Touch the ball there. Okay, so in this case, N is 4, because we have 4 states of the economy. And so we're going to have state 1, 2, 3, and 4. And so this R, I, comma, J, what does R sub I mean? Return of? Yeah, Supertech, right? And then in scenario J, so we're going to have scenarios 1, 2, 3, 4. And so we've got the returns of the stock in each of these scenarios. And so all we have to do is figure out what is the probability of the scenario times the return in that scenario, and then what does this thing mean? Sum, right? We're going to add all that together. So let's walk through the calculation for Supertech. We have, what's the probability of the first scenario? Yeah, 0.10, right? Okay, times what is the return in that scenario? Negative 0.30. Okay. Now, what is, by the way, if I do that, do you guys know that means multiply? Mm-hmm. Okay. Plus, what's the probability of the second scenario? Yeah, 0.2. These are not hard questions, by the way. What's the return in the second scenario for Supertech?
Negative.
Negative 0. Very good. Okay, plus, what is the probability of the third scenario?
0.5.
Yeah, 0.5. By the way, why do I write the 0? Because decimal places by themselves can confuse your eyeballs and you think they're not there. And so that's why I always write the 0. I don't know why they didn't do it on the slide. Okay, 0.5 times 0.2 plus, what's the last one? 0.2 times, yeah. Okay, now, there are a couple of things you could do here. You could do each one of these, and you could store them in your calculator. Store 1, store 2, store 3, store 4. And then you could just recall 1 plus recall 2 plus recall 3 plus recall 4. Or, if you're mathematically inclined, you can take a look at this. And let's see, now let's just go ahead and do it. Okay, so this one's going to be 0.1. You see how that is? What's half of 0.2? Okay, and what's 1/5 of 0.5? Yeah. Now it gets a little hairier up here. What is 1/5 of 0.10? Yeah, it's minus 0.2, is that right? And then up here, this is minus 0.03. Does that look right? Okay. Now, once again, you can do this on your calculator. I'd like for you to start thinking about doing things in your head if you can. 0.1 plus 0.1, what does that equal to? 0.2, right? And we've got minus 0.03 plus minus 0.02. If I add those together, what do I get? Minus 0.05, right? What's 0.2 minus 0.05? Oh my goodness. What's 20 minus 5? Very good. Okay, so we're looking at a 15% return here, or expected return. 0.15 or 15%. Okay, now I want you to look directly above all those things on the chart there, and it says SuperTech, and then it says something next to it. What does it say, Mr. Burstein? Yeah, it says expected return equals how much, Mr. Burstein? Right above. Right here.
Oh, so 0.15.
Yeah, 0.15, which is exactly what we got. Now, here's my point to you. Do I have to give you the expected return? Nope. Will I give you the expected return?
No.
Yeah, probably not, right? Probably not. In fact, I would prefer it not be on here, but you know, I got this picture from the publisher. Okay, now we can apply the same things to our other stock. Now the cool thing is here, because I have a dry erase marker, I can just erase, the probabilities stay the same, right? So all I've got to do is erase the returns in each of these scenarios and then fill them in with the returns in the new scenario, with returns from the new stock. So here we go. What is the return in the first state for Slowpoke? 0. What is the return in the second state? 0.05, right? What is the return in the third state? 0.2. And what's the return in this last state? Is it minus 0.05? Yeah, okay. So now we can figure this out. By the way, how much is this? 0. And I want you to notice this. What is 0.2 times 0.05? And this thing's got the exact opposite sign. What can we do with those two things? Yeah, just cancel them, right? And so what's left is just 0.5, half of 0.2 is 0.10. And so that is our expected return for Slowpoke. Look immediately above the stuff for Slowpoke, and it says expected return equal, and you get 0.10. So once again, our numbers are coming out in the wash here. Okay, now remember when we calculate standard deviation, variance, and all this stuff, one of the things we have to do is figure out the deviation for each one of these observations. And so what we're going to do is for each one of these, for SuperTech, we're going to take the return in that scenario minus this expected return that we've just figured out. And then that's going to give us a deviation. And just like we did previously, we are going to square that deviation. Now this is where it changes from what we did previously. Instead of adding up the squared deviations to get the sum of squared deviations and then dividing by the number of samples by, or divide by n minus 1, we are going to now multiply each one of those squared deviations times the probability that it's going to happen. Let me say that again. We're going to multiply each one of those squared deviations times the probability that it's going to happen. And so what we're going to do is, after we square it, we're going to take that 0.2025 for the first one and multiply it by 0.10. And we're going to do that for each one of those, and then when we're done, we're going to add all those together, and that's going to give us our variance. I see a concerned look. Okay. So, let's see if we could ask a question here. Oh, so we're going to get variance, and then let's see. I guess I'm bad with names today. Ms. Dowden, how are we going to get from variance to standard deviation?
Variance, square root.
Very good, square root. By the way, if you do the wrong thing in the exam, is it possible that the answer will still be there? Yeah, we call those close distractors, right? So, you'll need to know before we hit the exam. Okay, now, the next thing I'm going to tell you is there is no easy way to do these in the calculator, to find the standard deviations using this probability stuff. I'm going to show you the easiest way that I know how, and I've developed it over a number of years. So if you follow along and you keep an eye on my technique, I think you'll be able to do this pretty easily too. So get your calculator out. Keep skipping right, there we go. Okay, now, our expected return for SuperTech is 0.15. So what I'm going to do is put that in, store 0, just like we did last time with our mean that we were using to do standard deviation, because we're going to be subtracting that from each one of these things. I don't want to type that in again and again. So what I do to find this first one, and by the way, I'm going to work across, not down. Work across, not down. I'm going to take 0.3 negative minus, recall 0, equals. Does that give me the same number that we've got up here? It does. Okay, what's the next step? Yeah, we've got to square it. And does that give us the same number we had here? Yeah. And now there's a final step. I'm going to multiply by the probability of this state, 0.1, equal. And that gives me this last number right here. Any idea what I'm going to do with that number right now? Yeah, where am I going to store it? Yep, store 1. Okay, next one. 0.1 negative. What do I do next? Subtract.
Negative 0.
Yeah, recall 0, right? That gives me minus 0.25. What do I do next, Ms. Dowden? Oh, Ms. Dowden, you've changed your look. You're wearing a ball cap. What do you do next, Ms. Dowden?
Square it.
Square it, very good. Okay, and then, what do we do then? Yeah, multiply by that probability. Equal. And that gives me this number here on the end. Mr. Ali, what are we going to do with that number?
Store.
Where at?
2.
Yep, very good. Okay, now we have, who can tell me, Ms. Knight, what are we going to do next?
0.2 minus 0.5.
0.2 minus,
Oh, no,
sorry.
minus recall.
Yeah, 0.2 minus recall 0 equals, and that's going to give us the 0.05. Mr. Mersch, what do we do next?
Square.
Yep. Ms. Benias, what's the last step?
And then you multiply it by 0.2.
0.2? We multiply by the probability. What's the probability of the third state?
Oh, sorry, 0.5.
Yeah.
I was looking at the second one.
Yeah, the eyeballs play tricks on you after a while. And that gives us this number right here. Ms. Roll, what am I going to do next?
Store it.
Very good. And where at?
3.
Yeah, store 3. Ms. Raffel, what am I going to do next?
0.2.
Pretty sure?
Or 0.5.
Yeah. And then what am I going to do? Ms. Raffel?
Minus recall 0.
Very good. Mr. Breyer, what do I do next?
Square.
Square it. And then, Ms. Minahan, what do I do?
You're going to multiply by 0.2.
Yep, multiply by 0.2. Mr. Ali, what am I going to do with this number?
Store 4.
Yep, very good. Mr. Murs, what should I do now?
Sum them
How do I do that?
all. Recall 1 plus recall 2 through 4.
Yeah. There we go. Now, if I wanted to find standard deviation of this, what would I do? Square root it, right? So there's your standard deviation for this one, 24.19%. And that'll come into play later today. Okay, now, so let's go ahead and do it also for slowpoke. Ms. Dowden, how do I start out?
0.0,
Uh-huh.
and subtract that from
Subtract, oh, what do I need to do first though?
store.
Yeah, I need to change my expected return, right? Or I'll be in a world of hurt. Store 0. Okay, there we go. Now, back to you. Back to you. We start with 0 minus what?
Negative.
Recall.
Yeah, so recall 0, right?
Yep.
And that's going to give us negative 0.1. What do I do with this, Ms. Black? Square it. And then, let's see, you've been hiding, Mr. Drummond. Well, actually, you're just behind the camera.
A little behind.
Yeah, so what do we do now? You're on the top line there. We have just squared the deviation. What are you going to do?
Multiply by the probability.
Yeah, multiply by 0.1 equal. And Mr. Drummond, what are we going to do with that number?
Store it.
Yeah, store 1. Mr. Pulowski, what do we do next?
0.05
0.05? Minus?
equal 0.
0. Very good. Okay, Ms. Roll, what do I do next?
Square it
Square it. Boom.
times the probability.
Yeah, times probability. And what's the probability here?
0.2.
0.2. And then where do I store it?
2.
Yeah, very good. Okay, Mr. Ali, the next one is all yours. How do I get started?
Oh.
We're on the third one now.
So you just go and do 0.20
Uh-huh.
minus
Mhm.
recall 0
Very good.
and then take square.
Squared, okay.
Yes. And then multiply it with the probability of that.
Yep, and what's the probability for that one?
Is it second or third?
Third one,
0.50.
0.5. What do I do with this number?
Store
Uh-huh, where at?
second.
Oh, we're on the third line down.
Yeah.
We're on the third line down. Store what?
Third.
Yeah, there you go. Okay. Now, last one. Let's see, Mr. Murs, this one's all yours. What do I start out with?
Negative 0.05.
Yeah, so 0.05 minus, and then what do I do?
Call 0.
Yep.
Square that.
Uh-huh,
Multiply by 0.2.
uh-huh.
Store 4.
Very good. He's faster than I can type. Okay, now, let's see here. Mr. Breyer, what do I do next?
Recall 1 plus recall 2 plus recall 3 plus recall 4.
And I get negative .0, that can't be right. Now we gotta go back and see what's screwed up here. So I'm gonna say recall 1, that one looks right. Recall 2, that one looks right. Recall 3, that looks right. Recall 4, that one does not look right. Okay, so let's do that last one again, because I typed it in wrong. .05 negative minus recall 0 equals, and then we're going to square that, and then we're going to multiply by 0.2. There we go. Store 4. Now recall 1 plus recall 2 plus recall 3 plus recall 4 equals 0.011. How am I going to, Ms. Dowden, how am I going to get from this to standard deviation?
Square root.
Square root. Very good. And we're getting 0.10488 something, so it's going to come out to around 10.49%. Now, between these two stocks, which is riskier? The top one is 24.19%. The bottom one is 10.49%. Which one's riskier? Yeah, SuperTech is the riskier stock between these two. Questions so far? Okay, so far what we've done is we found a new way to find the expected value instead of just taking the arithmetic mean or the average. We are now doing this thing right here, which is kind of hairy. And we have also figured out that we are going to find our variance not by adding up the squared deviations and dividing by n minus 1. Instead, we're going to take each one of the squared deviations and multiply it by the probability that it happens. Now, most common mistake students make is they get to column 5 and they add those together and then take the square root of it and think that's the standard deviation. You've got to multiply each one of the square deviations by the probability or this is not going to work. Okay, so now we have the means and standard deviations for both these stocks. What distribution could we now generate for both of these? We talked about it last time.
Normal.
Yeah, the normal distribution, because you only need the mean and the standard deviation, or in this case, the expected return and the standard deviation, to be able to generate that. Okay, so now we're going to move on to something new. Previously, when we were talking about individual securities, we didn't talk about anything about how things move with respect to each other. But now that we're investing in more than one security, it starts to matter why these things move, or how they move together. Because we said earlier, if these things were moving exactly together, then the return of the portfolio is going to look just like the return of the individual securities. But what if they're not? What if they're moving in different paths? Then we have a chance to kind of even out the average return of the entire portfolio. And so it's important to know how these things move with respect to each other. And so the first thing we're going to do to try to understand that relationship is called covariance. Covariance. And it turns out that variance is just a very special case of covariance. Covariance is how, let's say, stock A moves with respect to stock B. Variance is just how stock A moves with respect to stock A. And so you're going to see here that this thing looks a whole lot like finding the variance, but instead of having the deviation squared, what we're going to do is take the deviation from one stock in a state of the economy and multiply it by the deviation of the movement of the other, the returns of the other stock. And so we can walk through this and see, and these deviations came straight from the prior slide. We know that for Slowpoke, the deviations were negative 0.45, negative 0.25, 0.05, and 0.35. We also know the deviations for Slowpoke. And so what we're going to do is go by each state of the economy and multiply the deviations together for those states of the economy. And so when I do that, for the first one, I take negative 0.45 times negative 0.10, and it gives me 0.045. What happened to the negative signs? Yeah, negative times a negative is a positive, so that goes away, just like it did when we were squaring things. And then the next one down, I have minus 0.25 times minus 0.05 gives us 0.0125, once again, positive, because those negatives are canceling out. And then in normal times, I have 0.05 times 0.10, which gives me 0.005, which is, of course, once again, positive. So far, everything looks just like variance, but there's a problem. Look at the last state. In the last state, the deviation for SuperTech is positive, and the deviation for Slowpoke is negative. And so when I multiply those things together, I get a minus 0.0525. Now, I cannot deal with negatives in the world of variance. We're going to get to this in a second here. We're going to see that this covariance is actually negative. So I'm not going to be able to take the square root of it in order to get some measure that's in a unit we can understand. Because just like variance, covariance is in units of percent squared. Just like variance, covariance is in units of percent squared. So it's really hard for us to interpret. Okay, now how are we going to do this last column? Exactly the same as we did with variance. We're going to take the probability of a state of economy and we're going to multiply it by the product of the deviations in that state of the economy. And then we're going to add all those things together just like we did for variance, and it's going to give us this covariance. Now, covariance as a number, like I said, it's percent squared, hugely difficult for us to interpret, except for one thing. If this number is positive, it means these things have more of a tendency to move together. If this thing is negative, it means they have a tendency to move in opposite directions. And we know that entire negative movement is being driven by the boom, right? Because that was the only time. By the way, if they're moving in opposite directions, the product of the deviations will be negative. If they're moving in the same direction, it'll be positive. So this negativity is being driven purely by the boom times, because that's the only time that we have a negative for column 6. So let's go ahead and walk through this and use our calculators to calculate covariance. Okay, now this time I'm not going to have to have an expected return that I keep subtracting. We've already done that. So I'm just going to start right here. 0.45 negative multiplied by 0.10 negative equal. I'm getting 0.045. Ms. Black, what should I do next? Yeah, multiply by the probability of that state, which is 0.1. And then Mr. Ali, what should I do next?
Do the same with the second one.
Okay, but do we want to do anything with this number before we do that?
Oh, we have to store it.
Yeah, very good. And where am I going to put it?
1.
Very good. I asked you on the first one this time because I know you have trouble keeping track. Yeah, okay. Okay, so now for the next one. Anyone want to take a shot?
Negative 0.25.
Very good. 0.25 negative, and then what?
Times
Uh-huh.
0.20. No, 0.05, sorry.
Yeah, and then what do I have to do?
Equal.
Oh, got to be negative,
Oh, so
right?
yeah, negative,
Yep.
sorry.
That's okay. And then that gets us 0.0125. What do we do beyond that?
Times the probability.
Okay. Times, and what's the probability here?
0.20.
Very good. And that gives me 0.0025. Where should I store that?
2.
Yeah, store 2. Okay, Ms. Raffel, what should I do now?
0.05
Uh-huh.
times 0.10.
0.10. And that gives me 0.005. What do I do after that?
Multiply it by the probability of 0.5.
Uh-huh. And then what should I do with that number?
Store 3.
Very good. Okay. Let's make sure I got that. I did. Okay. Mr. Drummond, what should I do for this last one?
0.35
Uh-huh.
times negative 0.15,
Mhm.
and then times 0.2,
Times 0.2
and
equals,
then store at 4.
store 4, very good. Okay, let's see here. Mr. Rosen, what should I do with these 4 numbers that I just stored? Oh, sorry, Mr. Burstein. Mr. Burstein, what should I do?
For the last column,
Uh-huh.
so take the 0.35 times the negative 0.15.
Well, so we've already done that, and so I've got these 4
Oh, so
numbers
add them
stored.
all up. So,
Yeah, very good.
Recall 1, 2, 3, 4.
Yeah. Very good. And that gives us our covariance. Now, let's see if Mr. Burstein was listening. Can I take the square root of this number?
Because it's negative now.
Yeah, I can't do it because it's negative. And so all we know for sure is that these things have a tendency not to be moving in the same direction. I can't tell you how extreme that relationship is, which is why we move on to something called correlation. Correlation is simply where we take the covariance between these two things and divide by the product of the standard deviations of each individual one. You remember I told you those standard deviation would show up later. Now, let's think this through. Covariance, I told you, has the same units as variance. What are they? Just Benioff. What are the units of variance and covariance?
Percent squared.
Yeah, it's percent squared. You're throwing your voice today, Ms. Benioff. Okay, so it's percent squared. Now, if I take that, and then by the way, standard deviation, what units are the standard deviation in? Percent, right? And so on the top, I've got percent squared, and on the bottom, I've got percent times percent. So what happens to all of that? And it cancels out. And so correlation, it turns out, is unitless. And you're thinking, wow, way to go, dumbass. You've gone from something that had a unit we can't understand to having something that has no units at all. Now, I'm going to tell you here momentarily why that's okay. But first, let's walk through the calculation. So we've got our covariance that just came from the last slide, negative 0.001. And we're dividing by the product of the standard deviations. Now, a little mathematical notation here. 2 to the 0.5 power is the same as 2 to the 1/2 power is the same as square root. So don't let that freak you out. At the time I made this slide, I didn't know how to do the little superscript fraction thing, right? Or I could have just put 0.0585 and put those square root bars over it. Didn't know how to do that either. And so this is what we've got, 0.0585 to the 0.5 power. By the way, did you know that the little caret means exponent, right? Okay. So we've got 0.0585 to the 0.5 power. That is the standard deviation of Supertech. We've got 0.011 to the 0.5 power. That's the standard deviation of Slowpoke. And when we do all this math, now we've got minus 0.039. And keep in mind that has no units whatsoever. And this number would be perfectly useless to us if it wasn't for one thing. And that is, we know that correlation is bound between -1 and +1. Correlation is bound between -1 and +1. And if you could guess what was in the middle, what would you think it would be? 0. Very good. Okay. Now that we know that, we can answer this question. Is this thing closer to +1, 0, or -1? Yeah, it's closer to 0. In fact, this thing is only 4% of the way toward -1. It's like, it's like right there. And so these things are actually more uncorrelated than they are truly negatively correlated. By the way, if someone tells you, oh yeah, those things have a correlation of 1.5, what should you say? You're an obvious dumbass, right? Because correlation only goes up to 1. And in the same way, if they say, oh, it's correlation -2, you know they're not quite right in the head. Does that make sense? So we know these things are bound. Okay, now let's talk about what these different things mean. Oh, we've already talked about that. Let's talk about these different kinds of states and how we achieve them. First of all, over here, we have what's called perfect positive correlation. Perfect positive correlation. Now, I'm going to give you an example of perfect positive correlation, and you'll say, oh yeah, that makes sense. Here we go. If stock A is up 1%, stock B is up 1%. If stock A is down 2%, stock B is down 2%. If stock A is up 3%, stock B is up 3%. That's perfect positive correlation. Here's for the part that'll blow your mind. Does it have to always be the same movement for both? And the answer is no. I'll give you an example. If stock A is up 1%, stock B is up 2%. If stock A is down 2%, stock B is down 4%. If stock A is up 3%, stock B is up 6%. As long as I could take the movement of one, divide it by the movement of the other, and always come up with the same positive number, then we have perfect positive correlation. In other words, it's the same fraction every time. In that case, it was either 2 or 1/2, depending on who you divided by what. But you get the same positive number every time when you take the movement of one, divide it by the movement of the other. That's perfect positive correlation. Now, let's talk about perfect negative correlation. Stock A is down 1%, stock B is up 1%. Stock A is up 2%, stock B is down 2%. Stock A is down 3%, stock A is down 3%, stock B is up 6%. Or sorry, 3%. I'm jumping to the next example. Okay, so basically, they're just mirror images of each other, right? If one's down 1, the other's up 1. If one's down 2, the other's up 2. They're just mirror images of each other. But it could also be like this. Stock A is up 1%, stock B is down 2%. Stock A is down 2%, stock B is up 4%. Stock A is up 3%, stock B is down 6%. And every time I take one of those and divide by the other, I come up with the same negative number. And so if I'm always coming up with the same negative number, I have perfect positive or perfect negative correlation. If I'm always coming up with the same negative fraction there or division, I get that's perfect negative correlation. Questions? So they don't have to be doing exactly the same thing. They could be doing a fraction of the same thing or a fraction of the opposite thing. Okay, so that covers perfect positive correlation and perfect negative correlation. And you can see, kind of demonstrated better graphically than what I just said, that basically when A is up in the first picture, B is up twice as much. When A is down, B is down twice as much, and so forth. Now look at perfect negative correlation. Basically, when A is up, B is down twice as much. And when B is up, A is down half as much. And so it's the same idea. Okay, so those are the ends. This is perfect negative correlation over here, by the way. But what about here in the middle? Here in the middle, we have zero correlation. And in fact, you can look at that picture there, and what happens with A has not one thing to do with what happens with B. What happens with A doesn't have anything to do with what happens with B. Any questions so far? Okay. So, now we're going to do some easy math. We're going to do the expected return for a portfolio. And we've already talked about expected return here for different states of the economy, but now I could do it for portfolio weights. I'm not even going to mess with that. We'll make this a whole lot easier. So what I have to do is I'm going to figure out a portfolio weight for each item in the portfolio. And the total value of the portfolio, I'm going to add together all the market values of the individual pieces. And by the way, it's important that it's market values, the market values of the individual pieces. And so and I didn't even have to tell you that it was a $100 portfolio, as long as I tell you it's a 2-asset portfolio and it's got $60 of one and $40 of the other. What does it have to be? It's got to be a $100 portfolio because 60 plus 40 is 100. Okay, now we know that we've got $60 worth of SuperTech, and we're going to take that 60 and divide by 100 to come up with the weight on SuperTech. What would 60 divided by 100 be? 0.6. Very good. Okay, now we're going to do the same thing for Slowpoke. Slowpoke is, I've got $40 worth of Slowpoke. What am I going to divide by, Mr. Ali? I've got $40 worth of Slowpoke. What am I going to divide by to get Slowpoke's portfolio weight?
Divided by total weight,
The total value, and how much is it?
100,
Yeah, so 40 divided by 100 gives me
the weight of.
the weight. He's not going to give me the number. It's almost like you did your grade school here in the U.S. You can't do that math in your head.
No, I did it in Pakistan, but we just like do 1 plus 1 even with calculators. I do it.
Oh my. Okay, so what's 40 divided by 100, Ms. Minahan? 0.4, very good. Now, of course, you could have cheated and looked at the slide and told me the answer, but you're an honest man, so at least I'll give you that, right?
Honesty is the best policy.
Yeah, it's very good. Okay, back to the story. Okay, so now I've got those weights. Now, how do I find the expected return for the portfolio? Well, all I'm going to do is take, for each of those things that's in the portfolio, I'm going to take the weight of that thing in the portfolio, and I'm going to multiply by the expected return of that thing. So that means I'm going to be taking the weight of A times the expected return of A. By the way, A here is SuperTech. And I'm going to be taking the weight of B and multiplying by the expected return on B. And then I'm going to add that stuff together. So here we go. In fact, let's go to the next slide. I think I actually have the numbers up. 0.6 times 15%, because the expected return on SuperTech was 15%. And then 0.4 times 10%. So 0.6 times 15% is 9%, 0.4 times 10% is 4%. What's 9 plus 4? I'm going to ask Mr. Ali. He's told me he can do this.
What?
What's 9 plus 4?
11.
Oh, damn! What is 9 plus 4?
I don't know. I mean, I know.
Oh.
Yes.
Oh my goodness.
Is it 13?
Very good. It's 13. Oh,
So sorry.
oh I'm so
Yeah, I
disappointed.
don't
You
do
just
that.
got through telling me you could do that.
Just myself with calculations, even 1 plus 1, I do not calculate.
Oh, that is such a shame. Do you guys know what an electromagnetic pulse is? It's when all of your electronic instruments get fried. It could happen from a nuclear explosion or other crap. How are you going to do your math after the electromagnetic pulse?
Fingers.
On fingers, with a stick in the dirt, right? Okay. Okay, so there we go. That's expected return in the portfolio. Now, there's another way we could go about this. We could have used the historical average for the return. So what if, instead of having population statistics, we had sample statistics like we had in Chapter 10? We could use the average return for our expected return. Does that make sense? But since we're doing the population statistics, we're going to use the expected returns as we've calculated them here. Okay, so that was the easy part. Now we're gonna do the hard part. And this formula gives us the variance for the portfolio. Now, I could have written that as, or just with the P, right? I want you to recognize that that symbol's the same as the symbols that we see further on in the equation. So, well, the first term here, I'm going to take the weight on a square multiplied by, can anyone tell me what that next thing is? So what's standard deviation squared? Yeah, it's the variance of A. And then we have the weight on B squared times, Ms. Benias, what's that next one? Sigma squared B, what does that mean? Ms. Roll? Don't know? Ms. Knight?
It's a variance.
Yeah, it's the variance on B. And then we're going to add 2 times XA, XB, and that next thing is covariance of A with B. Now this is confusing for people because we know that variance has this square up here and covariance does not, and it looks like the units of covariance should be percent, but they're not. They're percent squared, so don't let that freak you out. Okay, so we have we've got all these numbers from previously. So now what we're going to do is put those in. 0.6 squared times 0.0585. By the way, would you like me to walk through and show you what I would do with these if I were you on the calculator? Okay, let's do that. So get your calculator up. And we're going to say 0.6 squared times 0.0585. And we have that number from earlier. What do you think I'm going to do with this number right now? Store what? 1. Very good. And then we're going to say 0.4 squared times the variance of B, which is 0.011, equal, what do you think I'm going to do with that number? Store where? 2. Very good. And then we have 2 times 0.6 times 0.4 times 0.011 negative equals. What am I going to do with that number?
I think it's 001.
Oh, did I mess that up?
It just comes together.
Oh, okay. 2 times 0.6 times 0.4 times 0.001 negative. Is that right? Equal. Ah, phew, thank you. What am I going to do with that number? Store 3. Now, in order to find the variance of this thing, what am I going to do? Mr. Burstein, what do you think we're going to do?
Proof of the variance.
You're going to what?
Square root.
Oh, no, we haven't found the variance yet. So I've got these 3 terms in my calculator stored.
Add or equal. So you have
Yeah. Recall 1 plus recall 2 plus recall 3 equals. Now we're going to ask you, how would we get standard deviation from variance?
square root.
Yeah, square root. So when I do that, I get 14.95%. Okay, now right now that number doesn't mean anything to you because you don't have anything to compare it to, but we'll get to that here in a little bit. Now, let's talk about what would happen if we had 3 assets in the portfolio. By the way, I've told you before how many assets I have in my portfolio. It's over 1,100, right? And so if I were going to do this, I would have to do a whole lot of, it would be a huge equation. Let me just explain to you what a 3-asset portfolio would look like. Here we go. XA squared times the variance of A plus XB squared times the variance of B times XC squared times the variance of C plus 2XAB covariance of A with B plus 2XB XC covariance of B with C plus 2XA XC covariance of A with C. And you can see that this thing just gets nastier and nastier as we add in additional things into the portfolio. And so, no, we don't use this formula in the real world to find the variance of a portfolio. We'll use some mathematical means that I'll show you. Yes?
How come you have to, why do you have to square the weights for the first two numbers? Like when you do 0.6 squared times the variance, why is that number squared? It's a weight.
I will look up the derivation of this and send it to you. How about that? I will tell you this. Think about the first term has xa squared. The second term has xb squared. Look at the third term, xa times xb. Now, these things are actually unitless, but the mathematical symmetry tells us it's got to be that way, the same way that all these things have to have percent squared. But don't have a good answer for you, but I will find that and send it to you. That's not the first time someone's asked that, but I can't remember what the, so we could have actually derived this in class. In fact, I think I remember deriving it in a doctoral seminar. It was painful. Okay, good question. Other questions? Would the rest of you like to see that? No? Okay, I'll just send it to you. Okay, so, by the way, when you do these terms, what comes out is that you come out with two separate XA, XB, covariance of A with B. What you actually come out with is XA, XB, covariance of A with B, plus XB, XA, covariance of B with A. But it turns out that the covariance of A with B is the same as the covariance of B with A. And that XA times XB is the same as XB times XA. And so when you just collect those terms and put it to the number of it. So I can tell you that part of the derivation. Okay, so we figured out standard deviation for this portfolio is 14.95%, which is totally meaningless to you right now until we have something to compare that to. So you might think that the standard deviation of a portfolio would simply be the weighted average of the standard deviations of the individual components of the portfolio. But that would be wrong, and we're going to show you why. Remember that expected return on the portfolio, that's just what we would call a weighted average. That's all that is. It's just a weighted average. So the return on a portfolio is the weighted average of the individual returns. But the standard deviation we're going to see is not the weighted average of the individual standard deviations. So here we go. If we found the weighted average of the individual standard deviations, what we'd be looking at is the weight on A times the standard deviation of A, plus the weight on B times the standard deviation of B. And we just add those things together, and we would get 18.71%. We would get 18.71%. What did we get for the variance or the standard deviation of our portfolio? Yeah, it's 14.95. So which of these is lower? The 14.95, right? So we know that standard deviation is a measure of risk. And here's what's happened. We have been able to eliminate some risk. If we were taking on all the risk, if we hadn't eliminated any risk, the standard deviation of this portfolio would be 18.71%, but instead it's 14.95%. Now, let's talk about why that is. It's diversification. Remember I told you when these things move, and you will find out, they don't even have to move in opposite directions. They just don't have to move. If they don't move perfectly together, we still get some diversification benefit. So basically, the diversification benefit is this. We can get rid of risk. We can get less than the weighted average of the risk of the portfolio components while still getting the weighted average of the portfolio component returns. It's like having your cake and eating it too. Because we say risk and return have to go together, well, hey, we're actually able to dump some risk here without giving up return. That's magic, folks. That is really magic. And this is why I get so upset with people who own like one stock or only own like 5 stocks, because they're totally missing out on this magic of diversification. Okay, so how how can we demonstrate this? Well, I'm going to rewrite this formula. You recognize that formula up at the top. The second formula is for correlation. And this Greek letter rho is it's either the Philadelphia Phillies thing or it is correlation. That's how we write correlation. And so correlation of A with B is equal to the covariance of A with B divided by standard deviation of A times standard deviation of B. What I'm going to do is I'm going to rearrange that equation to get covariance of A with B, and then I'm going to apply something called the substitution principle. So I am going to multiply both sides of that equation with standard deviation of A times standard deviation of B. And it's going to cancel out over on the right-hand side, and then it's going to be multiplied over on the left-hand side, and then I just swap sides there because, we always want to be looking left or right. So the covariance of A with B is equal to the correlation of A with B times the standard deviation of A times the standard deviation of B. Now, the substitution principle says wherever I see correlation or covariance of A with B, I can substitute that other thing because after all, they're equal, right? They're equal, so I can substitute them. And so up in that top equation, it says covariance with A with B, I'm going to replace that with correlation of A with B times standard deviation of A times standard deviation of B. That's all I'm doing. I haven't violated any laws of mathematics. Okay, so once I've done that, we have the equation on the bottom. Now, do you think, for purposes of your note sheet, you should have both the top equation and the bottom equation on your note sheet? Yes. Do you think on an exam you should read carefully to see whether I've given you correlation or covariance? Yeah, because it's going to change which one of these equations you use. If I give you correlation, you're going to use the bottom one. If I give you covariance, you're going to use the top one. Okay, now why do we go to all that trouble? We're going to demonstrate something here. We're going to start with the assumption that the correlation is perfect positive correlation, and I've already demonstrated what that is. If we've got perfect positive correlation, then the correlation is 1, and I can plug it into this equation. And when I do, the variance of the portfolio turns out to be something like 0.035, and then I take the square root of that, and I get 0.1871 or 18.71%. Do you recall that that was the weighted average of the standard deviations of the individual components? That was, that's the number we already talked about, right? If I took XA times standard deviation of A plus XB times standard deviation of B, if I add those together, I get exactly the same number, 18.71%. So what does that tell us? It tells us the only way we don't get any diversification benefit whatsoever is if these things are perfectly positively correlated. Let me say that again. If I have perfect positive correlation, that's the only way I'm not getting diversification benefit. Because what if I lower that correlation anything below 1? Let's say we go to 0.999. Then that standard deviation comes down a little bit. And so, let me say this one more time. They don't have to be negatively correlated in order for us to get diversification benefit. It just has to be something less than 1. It just has to be something less than 1. Let me say that one more time. If we have any correlation less than positive 1, we are going to get some diversification benefit. Now, is it easy to find things that aren't correlated perfectly positively? Absolutely. In fact, I defy you to go out there and find 2 stocks that are perfectly positively correlated. And so what does that mean? It means we should go out there and just buy as many stocks as we can, because each additional stock that we add, as long as it's not perfectly positively correlated with the rest of the portfolio, is going to add diversification benefit. And so absolutely, we want to go out there and just do as many as we, commonsensically can. Okay. Questions? What do you think would be the absolute best correlation for diversification? So, common multiple choice question. What is the best correlation for diversification? Is it positive 1? Is it 0? Is it negative 1? Or none of the above? What do you think it is? It's negative 1, right? If we have negative 1 in this formula, that's going to give us the lowest possible result. We know we can't go below negative 1 for correlation, so that would be the absolute best possible outcome. And when we do that, what do you think we get? We can actually get it down to 0 risk. We can actually get down to 0 risk. I'll demonstrate that later. Okay, now, here's the bad news. Do you think there are things out there that are perfectly negatively correlated? I said one night, that was back when I taught night classes, I said, there's no such thing. And this guy says, okay, what about the S&P 500 and the anti-S&P 500? I don't even remember what the technical name for the anti-S&P 500 is. He says, aren't they perfectly negatively correlated? I said, yes, they are. I said, by the way, what do you think your guess is for the expected return on the S&P 500? He said, 12%. I said, then what's the expected return on the anti-S&P 500? He says, negative 12%. I said, very good. I said, now you're going to form a portfolio, half of one and half of the other. What's your expected return? 0, right? And so we have to put a caveat on here. Perfectly negatively correlated, and they both have to have a positive expected return, right? To keep people from making this anti-S&P 500 argument. Because otherwise you get 0 returns. And we know, even without taking any risk whatsoever, we can earn something called the blank rate. What is it? The risk-free rate, right? So we know that it wouldn't be good to form this portfolio that the young man proposed. Questions? Okay, so here is a real-world example of diversification. By the way, how many stocks are in the S&P 500? 500, very good. Okay, now you can actually think of the S&P 500 as being a portfolio of 500 different stocks. And the portfolio index, when on the date this thing was snapshotted, was 15.89%. Now I want you to look at all these companies that are beneath the S&P 500 index. What do you think they all have in common? They're all part of the S&P 500. So that's the first thing they have in common. What's the second thing they have in common? Take a look over at the standard deviations. How do each of their standard deviations compare with the standard deviation of the S&P 500? Yeah, they're higher. Now, I'm not telling you that every single stock in the S&P 500 has a higher standard deviation of returns than the S&P 500. I'm not saying that. But it's entirely possible. It is, in fact, this is a great test question, so write this down. It is entirely possible for a portfolio, to have a lower standard deviation of return, than the safest asset in the portfolio. And so we could have a portfolio that looked like this, where the portfolio standard deviation was even lower than any of the items in there. By the way, the safest one would have the lowest standard deviation, right? And so we could still have our portfolio standard deviation come in below that because of the diversification benefit. It doesn't have to be, but it can be. Once again, a great test question. Questions? Okay, that's the end of that set of slides. Let's move on to the capital asset pricing model. That's what CAPM stands for. Then we're going to start with the two asset case. So the two assets are the ones we've already been talking about. They're SuperTech and Slowpoke. And if you remember, Slowpoke had an expected return of 10% and a standard deviation return of 10.499%. So we're just calling that 10.5 here. And SuperTech had an expected return of 15% and a standard deviation of 24.19 something else. But so we're going to call that 24.2. So what we've got here is we've got return or reward on the vertical axis, and we've got risk on the horizontal axis, and we're just plotting these things there. Now we've got this third thing up there. It's the mystery square. And the mystery square has an expected return of 13, and that number at the bottom should be 14.95, not 14.93. So go ahead and change that on your slide, 14.95. What do you think the mystery square represents? What have we previously talked about that had an expected return of 13% and a standard deviation of returns of 14.95%? Yeah, that portfolio that was what, 60% SuperTech and 40% Slowpoke? When we put that up here, there we go, pop, right there. Now, what I want you to do is to attempt to draw a straight line between, oh, you're actually set up to do it well. Draw a straight line between Slowpoke and SuperTech. Can you draw a perfectly straight line, or as close as you can get to it, between Slowpoke and SuperTech? Once you get that done, I'm going to ask you this. Where does the mystery square land versus that line? It's above it, right? It's above it. That means that that's an illustration of the diversification benefit. If there were no diversification at all, that mystery square would be directly between those two. It would be directly between those two. And so what we're going to start doing is we're going to look at every possible portfolio that you can form with both SuperTech and Slowpoke. So starting down here at the bottom, it's 100% Slowpoke. And then we're going to start adding a little SuperTech into it, and every time we do, we're going to record the new standard deviation and expected return. And it's going to give us this curved line. It's going to give us this curved line. Now, the first thing I want you to know is that all of these new portfolios that we formed of a mixture of these things are above that line. So all of them are getting diversification benefit. The next question is, where on this line would you invest? Should you invest in 100% Slowpoke? No, why not?
I mean, you can just look at the graph for your expected return.
Okay, so you're saying if you invest in Slowpoke, you are getting an expected return of 10%, and you're taking on the standard deviation of 10.5%. But what if I added enough to get me to point MV? I've done an amazing thing. I have not only increased my expected return, I have decreased my risk. And so we say that no sane person would invest between Slowpoke and MV. By the way, Mr. Burstein, what do you think MV stands for? I'll give you
The minimum variance.
Oh, very good. It's the minimum variance. It's the furthest point to the left. And so if you're going to invest here, you would be crazy to invest in anything from Slowpoke up to MV. You could start investing in MV and then work your way up to SuperTech. Now, let's talk about what would drive someone along this line. We're going to call it the efficient set. That's the efficient set of things you can invest in, because this bottom part from Slowpoke to MV is not efficient. So anything from MV to SuperTech is called the efficient set. What's going to drive us along that line? The answer is risk aversion. Risk aversion. So if you are a healthy, sane individual, you are risk averse. And here's why. When you take risk, there's always a cost, right? And it may just be an expected cost, like for instance, jumping out of an airplane. Is it risky? Yeah. Is there, and when I say expected cost, what we're talking about is what's the outcome if things don't work right? Mr. Mers, how many people walk away from a bad experience in skydiving? Yeah, pretty much zero, right? So it's a, if it goes bad, then you die. Now, think about the percentage of probability that it's going to happen, multiply whatever value, negative value you place on death. That's your expected cost for going skydiving. Okay, so what we're looking at here is as people are more risk averse, they're less likely to take on these sorts of things. They're going to invest more out toward SuperTech. And I'll give you a skydiving example. When I was 18 years old, some of my friends are like, hey man, we're going skydiving. It's $300. You want to go? I said, I would love to go, but I don't have $300. And so then it's like 7 years later, I'm married, I have a mortgage and a good job, and I just suffered through 5 years of engineering school. And they call me and it's like, hey man, we're going skydiving again. They say, we hear you got that great job as an engineer, undoubtedly you've got the money now. So for sure you want to go. And I say, no way. What's happened to my risk aversion in the meantime? It's gone up, right? I am more risk averse now. Why? I've got more to lose. Plus, do you think I gained any wisdom between age 18 and 25? Yeah. Okay, so risk aversion is going to vary with a couple of things. Let's start with an obvious one. Who do you think is more risk averse, women or men? And we're just generalizing here and talking averages. Yeah, women are more risk averse, and I can prove it to you. Go out today on YouTube and put in stupid stunts and watch the videos and count the number of women involved versus the number of men. The number of men will vastly outstrip the number of women. Now the other thing is your age. The younger you are, the less risk averse you are. So my parents are 81 and 82 years old. They stare death in the face every time they get out of the bathtub, right? That's what it's like to be old. It stinks. So they are very, very risk averse. They like look at a sack of sugar and they're like, do I really want to risk throwing my back out? Right? And when I was much younger, I was much less risk averse, but now I am more risk averse, but I'm still not as risk averse as my parents. And so let's talk about where everyone would be along this line. You guys are probably going to be out there at SuperTech, except for, so I'm going to say probably Mr. Drummond will be out at SuperTech because he's young and he's male. Ms. Minahan is the same age, but she's female. Maybe she's at location number 3. And I am older and male, so I'm going to be at location 2. And it's hard for me to know about Ms. Rafael because she's somewhat younger than me, but she's also female, right? It would be really hard for me to know whether you're more risk averse than me or not. So let's not make that one. Let's talk about who's the oldest person in here? How old are you?
40.
You're 40. And you and I are older than that, right? That puts me down at MV in this. So let's put my parents down at MV, right? And by the way, one of them is slightly above MV and one of them is at MV. Who do you think's slightly above MV, mom or dad? Dad's male, right? So these are just generalizations, but these are things. And by the way, are there other things in your life that go along with this? Absolutely. What if you grew up in a society where things were very risky? You might be more risk averse, right? Okay. We will start here next time.